Welcome to the Explainer. Okay, let's dive right into this fascinating mystery of how solid bath bombs create gas bubbles out of seemingly nowhere. I mean, if you've ever dropped one of these powdery spheres into a tub, you've seen the explosive fizzy reaction, right? It's awesome, but scientifically speaking, we've got a real puzzle on our hands. In previous investigations, we actually measured the mass of bath bombs in a closed system, before and after they were crushed and before and after they hit the water. And we figured out, definitively, that we weren't just releasing trapped air. The gas was literally not there to start with. So, where in the world did it come from?
Because we know the gas wasn't just hiding inside the solid, we need to interrogate our ingredients to figure out exactly how you get gas bubbles from just a solid bath bomb and water. We are essentially dealing with a chemical whodunit here. And to solve this, we really have to look closely at what makes up the bath bomb. We need to strip it down to the raw materials.
So let's meet our suspect lineup. We're going to treat these standard homemade and store-bought recipe ingredients as our primary suspects in this investigation. Whether you buy a bath bomb at a fancy store or make one in your kitchen, you're going to see a lot of the same recurring characters. Baking soda is almost always there, sodium bicarbonate. You also frequently see Epsom salts, citric acid, cornstarch, different types of oils like coconut and olive oil, and sometimes even table salt or a lemonade mix. These are our suspects. But before we can test them, we need to understand how they actually relate to the bath bomb as a whole.
Right out of the gate, you need to know that the complete bath bomb itself is a mixture. That just means it's a blend of all these different materials mixed together. When you're holding a bath bomb in your hand, you aren't holding one single pure chemical. You're holding a carefully packed, mashed-up combination of several different things. But to figure out which part of this mixture is causing the reaction, we have to break it down.
To actually crack this case, we have to look closely at the individual substances that make up the mixture. A substance is made of just one type of material throughout. In science, we refer to these single, pure ingredients as substances. Baking soda? That's a substance. Olive oil? A substance. Now, the lemonade mix is technically another mixture, but for our baseline investigation, we really want to look at the pure, individual substances as much as possible. We have to isolate them to see how they behave completely on their own.
So, how do we tell our suspects apart? Well, substances in the bath bomb have properties that can help us to identify them. Every substance has a unique chemical fingerprint. We can identify them by looking at things like solubility, odor, state of matter at room temperature, melting point, density, and color. And notice how we specify room temperature? That's because temperature totally matters. Take coconut oil, for example. It has a melting point of 76 degrees Fahrenheit. If you hold a solid chunk of coconut oil in your hand, it's going to melt into a liquid because your body temperature is around 98.6 degrees. That's higher than its melting point. These specific properties are incredibly useful for identifying our suspects.
Now wait, hold on. This is actually a massive point in science. We need to make a crucial distinction between a true property which never changes versus characteristics like mass or shape, which absolutely depend on your sample size. If you have a giant scoop of Epsom salt, its mass, volume, and shape will change if you pour it into a smaller cup or grind it into a finer powder. But its color, its melting point, those stay exactly the same. Those are true properties. Properties are characteristics of a substance that do not change, no matter how much of the substance you're dealing with. And we're going to rely on these unchanging properties to track exactly what happens to our substances during this investigation.
Okay, to figure out which substance is responsible for the gas, we have to conduct the ultimate interrogation. We need to test just one suspect at a time in a glass of water. Think about it. The bath bomb didn't make gas bubbles while it was just sitting dry on the shelf, right? The bubbles only appeared when the bath bomb was added to water. So water is the catalyst here. We need to introduce each of our suspect substances to water, but we absolutely have to do it individually.
Here's our game plan. We have to carefully control our investigation by following a very exact procedure, ensuring no two ingredients accidentally cross-contaminate before hitting the water. Because, let's say we accidentally mix baking soda and citric acid in the cup before adding water, we wouldn't know which substance caused a reaction or if they actually needed each other to do it. So we isolate one clear cup of water, one single substance, and careful, precise observation. Now, when we add our suspects to the water, some of them seem to just magically disappear, which brings us to a vital detective tool, understanding how things dissolve. If you stir salt into water, you can't see the salt anymore. But does it cease to exist? No way. If we let the water evaporate, the salt would be right there left behind. Here's a cool little fact. The word dissolve has the root sol in it, which means to loosen. The solid substance is literally loosening its particles away from each other until they're so incredibly tiny that we can't see them with the naked eye anymore. They just mix completely into the liquid.
And this brilliantly illustrates our next set of properties: solubility. Is an ingredient soluble? Is it partially soluble, making the water kind of murky? Or is it entirely insoluble? This gives us fantastic data for identifying our substances. If a substance dissolves completely, like salt, it's water soluble. If it just sits there clumping up or floating on top like olive oil, it's insoluble in water. And sometimes it only partially dissolves, leaving the water milky or cloudy. This specific solubility is a fixed property of each substance.
So we ran the tests, and our observational data shows that while the ingredients react with water in very different ways based on their properties, none of them produced any gas. Seriously, let's look at the results. We meticulously tested the baking soda, no bubbles. We tested the citric acid. It dissolved, sure, but no bubbles. We tested the cornstarch, the oils, the Epsom salts. We got clear liquids, cloudy liquids, separated layers of oil and water, but across the board, the amount of fizz, the amount of gas produced was absolute zero.
This brings us to the massive plot twist of our investigation. When tested completely alone, not a single substance reacted with water to make fizz. Think back to our original premise. A whole bath bomb in water creates a massive release of gas. We proved the gas wasn't just trapped air inside the dry bomb, so we totally assumed one of the ingredients must be reacting with the water to create that gas. But our controlled, isolated tests just proved that assumption completely, 100% wrong.
So, the absolutely crucial takeaway you need to remember from all this is right here. Adding only one substance in a bath bomb to water does not cause gas bubbles to appear. Period. No individual ingredient is the lone culprit causing those fizzy bubbles. We've learned how to identify these substances by their properties, their solubility, odor, density, melting point, color. But more importantly, we've systematically eliminated every single substance in that bath bomb as a solo actor. The baking soda? Innocent on its own. The citric acid? Innocent on its own.
Which leaves us with a genuinely thrilling scientific cliffhanger. If no individual suspect is responsible, what exactly is going to happen when we start forcing them to combine? If ingredient A doesn't make bubbles and ingredient B doesn't make bubbles, could the magic happen when A and B meet in the water together? Are these substances teaming up to create something entirely new? Think about the implications of that. We've proven they don't do it alone. The secret to the bath bomb fizz absolutely has to lie in the combination, in the mixture itself. So what combinations will spark the reaction? And what new substance is actually being created in that bubbly chaos? Well, that is the next great mystery we're going to have to solve.